Hey everybody, hope you're doing well. This week we are going to be talking about testing, mostly in terms of unit testing for applications. But this video is kind of intended to give you a jumping off point if you are interested in some of the other types of testing as well. So more of a conceptual video and less of a technical, and the rest of the videos this week are going to be technical in nature. Um, Kind of highlighting the different technologies we've used this semester and how you can do some minimum unit testing on those. But one caveat with testing is that it is a field in and of itself, which means that it is a very, very broad, very deep, and you can get positions at companies strictly doing testing. There is a lot to it. And if you look at our program here, we have multiple courses on, you know, various testing approaches. Even if you take some of the software engineering courses, you'll talk testing in all its various flavors. For web architectures, testing is important too. It's still a software application. Now, this page that I have here is kind of a nice overview of testing in general. Um, it's going to cover the basics, so we'll talk a little bit about this, but unit test, integration, functional end-to-end, acceptance, performance, smoke testing, those are just a handful of testing approaches. There is um, a lot of exploratory approaches. There are very deep studies on continuous integration, DevOps pipelines, that kind of thing, which they talk about with the automated testing as well. But this is not the end all be all of testing. It is enough to kind of get you started if you're not very familiar with the different types. So let's kind of walk through the different types of tests, and we'll talk manual versus automated. Um, if you have never had a software engineering course before, testing is basically the idea of making sure that your program is doing what you say it's doing. And this is typically tied to something like a software requirement specification, a test specification. Basically, you as developers and engineers will come up with a document, an artifact of some kind that will specify my program or our application is going to do this thing. Here are all of the ways that this program will be accomplishing this thing or this goal, right? So it's not necessarily that you just sit down and write code and it works perfectly. You are going to write down exactly what you think your code should be doing. You're going to implement that code, and hopefully, when you're all done, that code does what your document says it should be doing, right? Because maybe that's what you agreed upon with your customer or with your users or whoever's buying this application or using this application if it's open source. So, bit of a dichotomy there. You have your code, you have your documentation. The testing bit is basically ensuring that your code is doing what your documentation says it should be doing. Take the world's simplest example, and we'll relate it to web pages. This web page's home page should be have or it should have a black background. Okay. And then programmer decides they don't like black, let's make it light gray. Okay, so the home page is now light gray. Looks fine, doesn't impact anybody, but it's not doing what your specification tells you to be doing, right? It's deviated. If you had a test case that was checking the value of your background color, it would fail. And it would pass if it was, pound 000 000 in your CSS. Again, simplest example. You can extrapolate to user interactions, performance metrics, all kinds of different things, right? But kind of the key here is that you are going to have a list of tests which are going to go through and make sure that your program is doing what it says it should be doing. Test case that passes means that your test case is looking at your code and it's telling you that your code is doing what the test case says it should be doing. There is another thing here too where your test cases don't necessarily imply that it's free of bugs as well, or your program's free of bugs. Maybe your test case was written poorly. Maybe your documentation is incomplete or inconsistent or vague. A lot of issues can happen here. Just, I want to kind of set the scene for all of this testing that we'll be doing and all the strategies that we can accomplish. So, and again, that's a completely different class. I just wanted to give you a little background there if you don't have it. But let's talk some of the different types of tests. And again, this blog or this page here is from Atlassian, so obviously their goal is to get you using Atlassian products. And they provide a lot of the automated stuff here. But if you are doing unit testing, which is what we'll be doing this week, it's the most basic function. It's the smallest piece of your software that you can test. So think a function, think maybe a class member. You could extrapolate it to be an entire class if it is fairly self-contained and small. But basically, it's like the smallest unit of your application. It's not a module. It's not five pieces of your application working together. It's not the system as a whole. It's literally one tiny piece. Does the input of your function match what you're expecting? Does the output of your function match what you're expecting? Right? So for instance, let's say that we are going to take in a number and convert it to a character. Because maybe we're doing an ASCII code lookup or a Unicode lookup or something. All right, so I pass in the number 42. Is the associated character coming out? So is the incoming value an int? Is the outcoming value a character? Is the incoming int within a range we expect? Is the outcoming character in a range we expect, right? Small pieces. And these are things which you can write as you're writing your application code as well. We could go down the path of test-driven development, where you write your test cases first and then you write your code. You could write your code first and then you test. Depends on your environment and your application and your organization and all that fun stuff. But again, lots of different approaches for this. So unit tests, smallest piece imaginable, right? And typically, all of our frameworks that we use in this class are going to have some form of unit testing built into the system. You may or may not have noticed it, but whenever you create a new React application or a new Rails application and you start setting things up, you're going to notice some test files automatically created for you as well. And we'll talk to those this week. Flask, we'll get into PHP, kind of touch on, but basically it's intended to be written as you write your code. If you're doing a Java application, you're going to get JUnit tests in there as well. Okay, so unit testing, in theory, that's what you should be doing. Not everybody does it, but you should be writing these as you go. Okay, integration tests. This is where, let's assume that you're working on a team. You have this module that you have developed, right? This thing works perfectly in isolation, works great by itself. Maybe you have some modules mocked up for dependencies that you may have to other modules, but your little package here works just fine. Okay? Integration testing is where you bring in another module, you hook them together. Does it still do what you're expecting it to do? Do the API hooks actually work the way you think they do? Does the behavior of your application match what you expect now that you have a real component in here? Basically, this is where you're mashing together two or more pieces of your application, trying to get to this cohesive system. Does it still function appropriately? All right. This is where you'll probably do this quite often if you're working in teams. You'll work by yourself, your teammates will work by themselves. At some point, you come together, bring everybody's code together. Probably not going to work right off the bat. And integration testing will tell you where and why. This is where you're basically verifying your requirements. Maybe it's your business requirements, your customer requirements, internal requirements, but this is what you would typically think of when you're testing a system. Now, basically, functional tests are very value driven. They tend to be very specific, very easy to test. Like I'm checking the range of a value for a voltage, or I'm looking at, do we get a database result from our system? Kind of like unit tests, but a little bit broader in scope. Again, more requirements driven versus functional prototype driven, I suppose. End-to-end tests, acceptance testing, performance testing, smoke testing, these are all deeper layers. Acceptance would be, does your customer agree that your system is doing what it says it should be doing? You'll have different requirements for your customer. End-to-end tests might be from start to finish. User creates an account, user logs in, user gets their portfolio page, user updates their profile. Does everything work as you expected flow-wise? Smoke testing could be just seeing, does your application work as you're intending? Are you getting any weird code smells out of this? That being something seems wrong. Maybe you're following an anti-pattern or something like that. And again, you can go way deeper into this too. There's also something called regression testing, where you have your code, it has passed all your tests. You go back and change something because you realize you didn't implement a requirement correctly, or something's out of date, or you got new requirements. Okay, does your code still work the way you expect it to be doing? That's another area of testing. Um, and in terms of, again, testing, there is just so much more that we can be doing. But these tests are at least some of the basics that a lot of companies will do. And the other thing here too is that we can do it manually or automated. So manual testing is what you're all going to be at least watching this week. Um, that is where you are manually kicking off a testing procedure. So you tell React, run the test scripts, or you tell Rails, run testing, or Flask, let's do testing, okay? You run your test scripts, which will in turn execute whatever test suites are going to be required. Test suite being a collection of test cases. You get a report at the end, you see what passes, what fails, you get information about each failure, all that fun stuff, right? The automated testing is where you have some kind of a continuous DevOps pipeline. So like a continuous integration, continuous deployment, the CI/CD thing. That would be where you push your code up to GitHub, or you push your code up to Subversion or something like that. That triggers a build process, which gives you an executable of some kind, right? Maybe it's an application or it's a web application or whatever it is. That in turn will kick off your testing procedure, which will then run all of these tests which you have defined and said run. And then you get emailed a test report, or it will show up on the page that you push to or something like that. That can save you some time. That's becoming more and more common these days to have a pipeline like that. Both will have their place. So manual testing, obviously, you get a more hands-on, detailed approach. CI/CD, hopefully your testing scripts don't go out of date, because then that becomes a whole other thing. Anyway, again, this was more intended to kind of get us in line with testing and what we have to be doing. The rest of the videos this week are going to be mainly deploying and executing tests in the various frameworks we've looked at, mostly unit testing focused as well. But other than that, hope you have a great week, and I'll see you around. Bye, everybody.